Percent composition. For this video lesson, you will need your yellow objective packet, your Unit 3 notes packet open to page 15, a pencil or pen for taking notes. In your yellow objective packet, circle objective 10P as part of your Unit 3 objectives. This objective asks you to determine the percent composition of a compound from its chemical formula. As you learned playing with the Lego structures, percent composition is the percent by weight of each type of piece making up the whole structure. The same idea will hold when calculating the percent composition of chemical compounds. For a chemical compound, the pieces are atoms, and the percent composition is the percentage by weight of each element in the compound. For example, the percent composition of sodium chloride is 39.34% sodium and 60.66% chloride. Although the compound is made of one sodium ion and one chloride ion, the percent chloride is much higher because a chloride ion is so much heavier than a sodium ion. Let's look at an example. NO2 is a brown gas that is the primary substance responsible for the brownish color of smog. Let's calculate the percent composition of NO2. This problem is asking us to find out what percent of the mass of NO2 is nitrogen and what percent is oxygen. Unlike finding the percent composition of your Lego structure, you do not know the mass of your sample of NO2. Luckily, percent is the same regardless of the size of the sample. The easiest sample size to use here is 1 mole of NO2. Using the periodic table, we can find the mass of nitrogen in 1 mole of NO2 to be 14.0067 grams. The mass of oxygen in 1 mole of NO2 is 31.9988 grams, and the total mass of 1 mole of NO2 is 46.0055 grams. Like all percentages, percent composition is part divided by whole times 100. In this case, mass of element divided by mass of compound times 100. To calculate the percent nitrogen, we simply take the mass of the nitrogen in 1 mole of NO2, divide by the total mass of NO2, and multiply by 100. Notice that the answer has a large number of significant figures due to the large number of significant figures provided from the atomic masses. Now we can do the same thing for the oxygen. The percent oxygen is the mass of oxygen in the NO2 divided by the mass of 1 mole of NO2 multiplied by 100, giving us 69.5543% oxygen in our NO2. From this video lesson, you should now be able to calculate the percent composition for any compound.